Alright, and then let's find the volume, an actual volume using spherical coordinates. So we've got a what we call the ice cream cone problem. We've got a cone on the bottom. The cone is just phi equals pi over 6. Okay, remember, if phi is pi over 6, that's a constant. That's just an angle. So we would just go along this angle coming off pi over 6, and we would rotate all the way around with theta, and we would create that shape. But we're bounding it above by the sphere, just rho equals 1. So we got this sphere above this cone, and that's what we're going to try to set up and find the volume for. Alright, remember, if we set up a triple integral, we're technically finding a hypervolume, a fourth dimensional idea, but if we make the function to integrate, the integrand, if we make that 1, then we do get volume, just like we did with area. So I'm going to set this up now. Let's look at our picture again. So even though our even though our function, our integrand is going to be 1, we still, because we're doing spherical coordinates, we're going to have the rho squared sine phi. But what are our limits of integration going to be? Well, rho obviously is going between 0 and 1. So from here all the way up to here. So thinking about, if I have this spherical idea, if I just, have it with, a tenth, if rho is a tenth, if rho is a quarter, if rho is a half, if rho is 3/4, all the way up, every value in between there, I could go between these cones for different values of rho, all the way up to rho being 1. So rho between 0 and 1 along these angles. Alright, now, what does phi go between? Well, phi obviously goes between 0 and pi over 6 to go out to the edge of the cone. And then theta, to get the entire cone, will have to go between 0 and 2 pi. So don't forget our rho squared sine phi. Alright, then d rho, d phi, d theta. Rho is going between 0 and 1. Phi is going between 0 and pi over 6. Theta is going between 0 and 2 pi. All these are just constants. Okay, that's what makes these problems so much nicer than if you try to do this rectangular. Alright, we're doing rho first, so we're going to get a rho cubed over 3. We're going to plug in a 1 and a 0 into that thing. Alright, so we'll have 1/3 and 0, so just the 1/3. I'll pull it out of the integration just because it's a constant. Now this is d phi, so whose derivative is sine? The antiderivative sine is negative cosine. Alright, the cosine of pi over 6, when I plug that in, would be the square root of 3 over 2, but it's negative, so negative square root of 3 over 2. The cosine of 0 is 1. Alright, we're subtracting that, so it's negative 1, and we're subtracting that, so we'll get positive 1 minus the square root of 3 over 2, right, which I can simplify to, multiply it. I'll pull it out of the integration and multiply it by this 1/3. So 1 minus the square root of 3 over 2 times this 1/3, and then I'm just 0 to 2 pi d theta. Once again, that's just going to multiply that by 2 pi. Alright, and so what happens is if I multiply this, what I currently have, by 2 pi, so I've seen this multiple times, this just simplifies to just 2 pi, 0 to 2 pi, just delta theta. So if I distribute this in at the same time that I'm distributing in that 1/3, I'm going to get a, if you notice what's going to happen, 1/3 times 1, 2 pi, I'll have a 2 pi over 3, right? 2 pi over 3. And then when I distribute the 2 pi in, I'll have a 2 pi minus, and this guy right here would be a 2 pi square root of 3 over 2, so the 2's would cancel, and then a 3 that comes in from that. So I'd have a square root of 3 over 3 times pi, and it simplifies to this. So 2 minus the square root of 3 over 3 times pi is our volume.